Hello student, let's try to see the question number 34 student. This is the CBSE question paper student 2023. Student, what the problem is there? 5 marks question is there. Manganese exhibit the highest oxidation state +7 among 3D series of transition metal. Okay. Chromium highest is there student +6 and manganese they are saying how much is there +7. Now student, if you see the Mn, what is the configuration student 25? It is there student 3d5 and 4s2. So total valence electron, you check how many valence electron are there. Total valence electron are there 7. So it is going to lose all the 7 electron. So Mn 7 plus 7 electron will be out student. So this Mn 7 plus losing 7 electron, it will acquire the configuration of the pseudo inert gas configuration like the argon student. So this becomes the stable. That is why it is representing +7 oxidation state. Here you see the CBSE itself given the explanation due to participation of 3d and 4s electron. So 3d electron how many are there? 5. 4s how many electron? 2. So total electron is how much student? 7. In the bond formation due to the presence of maximum number of unpaired electron. So because of this student, either if you are writing up to here due to participation of 3d and 4s electron in the bond formation, or you can also write student this second part due to the presence of maximum number of unpaired electron. This could also be the correct one. So CBSE has given the 1 marks for this one. Now next question, let us try to understand. Transition metal and their compound generally found to be good catalysts in the chemical reaction. They have the what student? Free valency student. No, transition metal, suppose it is Fe is there. On the surface of Fe there is free valency. These are because of the presence of free valency, they act as a catalyst student. Here what the reason? Due to variable oxidation state or due to availability to adopt multiple oxidation state or due to large surface area or due to complex formation, it act as a catalyst. So how many answer is acceptable in the CBSE student? Either you write due to variable oxidation state, that will be accepted, or you can write due to availability to adopt multiple oxidation state, that is also correct. Due to large surface area, correct. Due to complex formation, this is also correct. So out of the 4, anyone you can select student, that you will get. So here the due to large surface area, I have also selected this one. The transition metal is having large surface area or they are having the free valency student. Large surface area means free valency. So because of that they act as a catalyst student. Now Cr2 plus is reducing in nature while the same d orbital configuration d4 of Mn3 plus is oxidizing agent. अब now student you see Cr2 plus it is configuration is 3d5, right? 3d5. If you split this 3d5 student, how it is going to be like that? Here you see. So in this case, if you see, it is acting as a reducing agent. How can it act as a reducing agent student? Because if it lose 2 electron student, if it lose 2 electron, so what it will be acting as a stable configuration, it will acquire. See, Cr2 plus changes from D4 to stable filled T2G configuration student, stable T2G configuration. So confirmation. So this configuration. So here is the d orbital. If you see Cr2 plus, it is d4 student, d4. So if it will lose 1 electron student, so what will be there? Here only 3 will be left. Okay, if it is losing 1 electron minus, so it will left stable T2G configuration, T2G3. So because it is losing the electron, 1 electron, so it will act as a what? Reducing agent, Ra, reducing agent. Now let us see the next part. What is there? Mn3 plus is oxidizing agent. Mn3 plus is oxidizing agent. Where is the Mn3 plus is oxidizing agent? So Mn is how much, student? 25. If you see the configuration 3d5 and it is 4s2, student. 3d5 4s2. Now in case of Mn, student, 3 plus, it will have the 3d5 configuration. 3d5. If you see, student, what it can do here, it act as a oxidizing agent. They are saying it is acting as a what? Oxidizing agent. So how can you it act as a, see, 1 2 3 4 5. So one more electron, accepting electron, if it is electron pair acceptor, means the oxidizing other and self reducing, so it required one electron, that is why. Now see the answer, student. While Mn changes to stable half filled configuration d5, either you can say d5 also, student. Mn3 plus means it is the 4, student. No, one electron here, two electron, Mn4 plus. So if you taking one electron, student, what is going to be the configuration is going to be what? The simple is the d5 configuration. So both way you can explain, student, either with the help of crystal field theory or the normal. So here in this case, that is, if you are accepting one electron, student, so it will become 3d5 and stable half field. So anything accepting is electron stable, electron, student, that will become the oxidizing agent. Now let us see the next question, last one. Zn has lowest enthalpy of atomization because it is having completely filled orbital, student. It is having the lowest due to absence of unpaired electrons and weak interatomic interaction. It is how it will be lowest enthalpy of atomization. Next one, copper plus is unstable in aqueous solution. Copper plus, because it disproportionate, student. Copper plus ion undergoes disproportionation, student, to form Cu2 plus and Cu. So 2 Cu plus, it is giving Cu2 plus and copper, student. So because of this, student, these are what they are going to do, student. 2 Cu plus, it is giving Cu2 plus plus Cu, student, and which result in the stable what, student? Instability of this one because it is disproportionating. This is all about the answer. Thank you, student.